Hi, everybody. Welcome to our lecture video on section 3.7, which is adding and subtracting fractions. And this is a direct extension in some ways of what we did when we compared fractions. So we have a nice rule. If the denominators are the same, you can add or subtract the numerators. So if I take 3/8 and I add to that 13/8, because those denominators are the same, that's 3 plus 13 over 8. And let me just show you here. Let's see. I'm going to do a square. Not a square, a rectangle. Okay, I've got 8 little squares there, and I take 3 of them. And then I have 8 plus another 5. To get 13 altogether. I really should use a different pen color. Here, let's do this, just to make clear that that's different. And so I'm going to take these 3/8 and I'm going to fill in the gap. I've got my 8 and the 5 and then those extra 3, right? Which is, oh, it's a total of 16/8, which is actually those 2 whole rectangles. So if your denominators are the same, you can add or subtract the numerators. Let's look at 17 fifths minus 4 fifths. So I can write it as 17 minus 4, all divided by 5, which is 13 fifths. Of course, this counts on me doing my arithmetic correct. So if I do my arithmetic wrong, please catch me. It's probably, I was already doubting myself that 17 minus 4 equals 13, but I figured I'd go for it. So yeah, I might do my arithmetic wrong in this section. Okay. So that's if the denominators are the same. And guess what? If the denominators are different, first, make them the same. And that's exactly how we did it when we were comparing fractions. I compared 4/7 and 2/3. Now I'm going to add 4/7 to 2/3. And I can't add them if they don't have the same denominator. With multiplication, you can, right? You just multiply the denominators. We do not do that. We do not say 7 plus 3 on the bottom. In order to add fractions, they all have to be the same, the parts of the same whole. right? Here, it's 3 out of 8 and 13 out of 8. And so we can add, because these shapes have to be the same, if you want to think about it that way. So what I have to do is I have to rewrite each fraction by multiplying it by the missing piece. The missing piece for 4/7 is the 3. And the missing piece for the 2/3 is the 7. And then I will do some of that multiplication. I get 12 over 21 plus 14 over 21. And now they have the same fraction. So now I can add the 21. Now I can add the numerators and I get 26 out of 21. If I did it the other way, if I did it the wrong way, and I said 4/7 plus 2/3 equals 4 plus 2 over 7 plus 3, I'd have 6 out of 10. Right? So I won't go through every detail why this is wrong, but I can tell you this much. 4/7 is going to be like this. 2, 3, 4, 5, 6, 7. Right, 4/7 is this much. 2/3 is this much. When I put these together, I'm definitely going to have more than a whole circle, right? Because I got more than half a circle and more than half a circle. But 6/10, that's only like that much. All right, that's simply not possible. I can't take more than half a circle, add it to more than half a circle, and get only a little bit more than half a circle. So this is wrong. And then now that you know that it's wrong and you know that it's right, the rest of it is just practice. So you need to do this enough times so that when you see fractions that have to be added together, your instinct is get them over a common denominator before I add them. And if you do that enough times so that 10 out of 10 times you remember to do that first, then you'll get it right almost every time for the rest of your life, which is the goal. So let's just do a couple more examples. And I'm gonna just grab the ones I did before in the previous video. Yeah. 17 over 24 plus 23 over 36. Reason I'm doing this is mostly so I don't have to do lots more arithmetic in the morning because I already have what those various conversions are. 17 over 24 plus 23 over 36. They do not have the same denominator. So I need to get them over the same denominator. And we're going to do this in two ways. We're going to do the least common multiple way. And then we're going to do the I'm lazy and I just want to multiply the denominators. Maybe it's not lazy. Maybe I've decided it's going to be easier. So the least common multiple way would say the 17 over 24 is missing a 3 in order to get it to 72. And if you're watching on the video and you can't remember how I got the 3 over 3, go back and review the other video. But basically, I counted by 24s, that's a 48. Counted by 24s until I got to 72, and I counted by 36s I needed 3 of my 24s, and I need 2 of my 36s. And then I do the arithmetic, and I have 51 over 24 plus 46, nope, 51 over 72 plus 46 over 72. That's 97, I think, over 72. And I believe that I'm done, because I don't think that 97 and 72 share any common factors. In fact, 97 is prime. And so if I do the multiplication denominator way, then I just multiply by the missing denominator. Which also gets me over a similar denominator. So I'm going to get 612 over 864 plus 552 over 864. Which is 1164 over 864. Which is the correct answer, but it is not reduced. So I'm fine with the fraction 1164 over 864. That is the answer. It's a correct answer. It is the fraction. It's not reduced, right? It's not 97 over 72. So if you wanted to get it in the reduced form, you'd start to have to peel off numbers. So this multiple denominator or multiply the denominator is really great when you're comparing fractions, because you just get to here and you don't care. It can be less useful when you're trying to add fractions if you want to end up with a reduced fraction. But I can still reduce it. I know 1164 can be multiplied by 2 because it's even. Which becomes 582. And 864 can be reduced, can be divided by 2. So it's 2 times 432, and those cancel. And I still have even numbers on the top and bottom, so I can divide by 2 again. 582 over 2 is 291. 432 over 2 is 216. So there's a 2 times each of those, and those cancel. And I don't know if this can be reduced anymore, but I can always try some numbers. All right, so 5's not going to work because they don't end in 5s. 2's not going to work because the top one's not even anymore. 7 might work. I haven't tried 3 yet, though, so let's try 3. Oops. 291 over 3. Aha, that gets me to the 97. And I'll get the 216, and sure enough, it's 72. And those cancel. And I check 97. I have to check a whole bunch of different numbers. I have to check 2, 3, 5, and 7. But I know it's not 2. I know it's not. I could check 3. It's not going to be 3. I know it's not 5. Check 7. Doesn't work for 7. So I end up reducing to the same fraction. So either way works. right? You either do the work on the front end by finding the least common multiple, or you do the work on the back end by reducing your fraction as much as you can. Honestly, I think probably the least common multiple is an easier way to do it. Because it's more of a building, right? It's a Lego process. You just count by your denominators until they match. And the multiply the denominators method, it's more of a puzzle where you have to try different factors. So let's do another one. Let's do 32 over 42 minus 58 over 36. Again, there's a couple ways you can approach this. In this case, like I could reduce 32 over 42 because they're both even. And actually, I could also reduce 58 over 36 because they're both even. So you could do a little bit reducing beforehand, which can make your finding the least common multiple simpler. But I'm not going to do that because in general, there are lots of right ways to do math. Flexibility is good, but I also think it's a good idea to learn something and learn it really well before you start worrying about other ways to do things. So in general, for adding and subtracting fractions, let's use the least common multiple approach until you feel like you got it down really well. So I'm going to count by 42s, 42, 84. It's absolutely okay to turn to a calculator. 126, 168. Let me count by 36s a little bit. 36, 72, 108, 144. Yeah, it's not working yet, but that's okay. I should have given myself more space. Let's do this. Okay, so back to the 42s. 168 plus 42 is 210 plus 42 is 252 plus 42 is 294 plus 42 is 336. Okay, let's go back to the 36s and see if we get anywhere. 180, 216, just missed it. 252, aha, found it. 252 works. The counting in parallel will work. We could do this also by finding the prime factorization and the missing primes, etc. Right? But let's get one way that works really well and get super comfortable with it. So 252 is my target denominator. And so how do I get from 42 to 252? I need 1, 2, 3, 4, 5, 6. So the 42 is missing 6. And how did I get from 36 to 252? I count my steps, 1, 2, 3, 4, 5, 6, 7. So the 36 is missing a 7. And how do I know if I did that right? Well, you're going to do the multiplications of the denominators, and they should both get you to 252. (42 times 6, 252. That's good. 36 times 7, 252. That's good. All right. So I got the denominators where they need to go. And now I check get the numerators. 32 times 6, is 192. And 58 times 7 is 406. This is not a fast process for sure. And there are a lot of steps to keep track of, which is one reason why your worksheet is pretty short, because it can take a while to work through those questions. But if you remember different denominators, okay, let me find the least common multiple, however long that takes. And then get the denominators to be the same. Now I can do that subtraction because the denominators are the same, which is 192 minus 406 over 252. I get negative 214, all divided by 252. That is my answer. Is that answer reduced? It isn't, because they're both even. So I'm fine with this, but probably my open math is going to want a reduced fraction. And that's going to continue giving you practice, which is good. So they're both even, which I could write therefore as 2 times, let's see, that's negative 107. That one I can do in my head, okay. And this is going to be 2 times 126. Again, I can do that one in my head, okay. And the 2's cancel. I get negative 107 over 126. And I don't know if that's reduced or not, because maybe they share some primes. And there's a couple ways to go about this. We could check all the factors of 126 into 107, or we could find the factors of 107. 126 is even, but 107 is not. So 2 is not going to work. Let's just check 3. 107 divided by 3. It's 35.666, so that doesn't work. I don't have to check 5 because it doesn't end in a 5. Let's check 7. It doesn't work with 7. And by the way, this is a common mistake. Just because the number is 107 doesn't mean it divides by 7. Right? So 107 doesn't divide by 7. The next prime is 11. That doesn't work. But I don't even need to check 11, because what's the square root of 107? I don't have to go to 11, right? Because 11 is bigger than the square root of 107. So I've checked my primes. 107 is actually a prime number. So that's my final answer. Negative 107 over 126. All right. I'm going to talk a little bit more about this on Wednesday, just as a reminder. But for now, I'm going to pause, stop the recording.